Okay, in this video I'd like to show you a two-dimensional or 2D NMR experiment. And this experiment here is a COSY. It's a very classical experiment. COSY stands for correlation spectroscopy, CO for correlation, and S first letter of spectroscopy, and letter Y is the last one. This experiment shows us the correlation between protons that are in proximity to each other. We are all used to see coupling constants between geminal and vicinal protons, so this means 2 or 3 bonds away from each other. So this is why we see our doublets, triplets, or DT systems or whatsoever. This technique can be used to show the connectivity of a larger molecule. In our molecule, the ibuprofen, we don't have so many connected protons, but nevertheless we can use this one as an example. When you get your COSY experiment, it may look in different ways. So it may look a little bit like mine here at the moment with some lines. If I use my mouse wheel, then the spectrum may even look like this one. So that is also something you sometimes see. So you can adjust it first of all with your mouse wheel until you just don't see the vertical lines anymore. This one here is quite a concentrated sample, so you can wheel it down quite substantially. Also, I said this one is in principle an experiment which bases on protons. If a COSY is being run, you need always a proton spectrum. Sometimes this is baked into the experiment, so you basically get already a proton quickly run before the COSY is run. Or you can also run a separate proton NMR experiment and then top it up with a COSY. So for this purpose, you can make also the traces visible, because if you look here at the spectrum, then you see here we have the scale that is equivalent to a proton scale, and here's another one. So it's a two-dimensional proton spectrum. So the traces are conveniently shown here in MNova, so you can just click on show traces and then they turn up. Sometimes this doesn't work and then you have to run a setup, so especially if you have run a proton externally. So here's an external one. I had already selected this one. You normally confirm where you want to use it just by clicking those buttons and say OK. And now we have our external nice proton aligned here. Normally it's quite useful to print out a COSY spectrum in the right size and then use a ruler and a pencil in the beginning. However, we can also do this on the screen. So I start by drawing here a line, and I will draw this line just across the spectrum. So what you see here is now that I have halved my COSY spectrum. And there are quite a number of little islands, little cross spots on this diagonal. This diagonal shows me that every signal correlates to itself. So if I go down here, maybe I should use an arrow. If I go down to this, from this doublet into the cross peak, and then drag a long line across from the cross peak, then I will turn up at the same signal. And I could repeat this one with every single one. MNova has the option to do the assignment more or less automatically, but usually requires that you have the predict tool. As an undergraduate student, you usually don't have a predict tool. However, we can use the crosshair tool. Here we have the crosshair tool, and this one works in a way that I just move my mouse pointer around and then I can see how lines are connected to each other. So let's select this signal here. This signal is a quartet, and if you remember correctly from our proton analysis, this is a quartet because it's the position here, number 11, that is coupling with the methyl group in the ibuprofen. Luckily, this one is not coupling to this side because there's no proton on this carbon, and it's not coupling to this side. So it's quite a simple connection here. So from here we should see somehow where this methyl signal is sitting. How do we do this? We look for the CH signal and then check, it goes to itself, and now we see on this line that there is an island here in between, and this island basically tells us where the cross peak is. So at the moment you can see the mouse is kind of floating all the way. So the trick is to press down the shift button. So if you hold down the shift button, then you get to see the whole square. So now you can clearly see where the CH3 group is setting. It's roughly at 1.5. To the side you have a window. If it would be a bit bigger, then you could see it. It just peaks out there at 1.4928 with 4 decimals. So by this we have basically found this connectivity. Let's have a look at another part of the molecule. Let's start from one of those CH3 groups. We know that they're at the same place. So here we find them. So let's have a look how these are connected. So we would expect that those are both connected to this CH group, which should get something like a no net or so. Quite a complicated signal. So can we find this one? So I use my crosshair tool again, hold the shift button down. So I have my crosshair on, and it's a bit tricky to play with this one. So now it's in the cross, and now I try to find where it is going so that I form a square where all the spots both on the diagonal and the islands are connected, and this gives me the next signal, and that's the one around 1.86 obviously. So 0.9 and 1.86, these are the signals that are connected to each other. So by this I've found the connection from those two to this one here. So I know the next signal is at 1.8687. So this one should now be connected to the CH2 group. How do I find this one? I move around until I find the next cross peak, and that one brings me then to a signal at around 2.45. And if you remember correctly, this was actually a CH2 group, so this means here we have found the next connection, and then we are obviously stuck. We can still look at our aromatic signals, and we can only see that they are actually coupling with each other, and that is something we would have expected as well. As I have shown in the beginning, COSYs are often easier analyzed by paper and pencil copies. However, I would like to show you two additional tricks that are useful when printing out your COSY. So first of all, once more back to the crosshair tool. We know that this doublet here is coming from those two methyl groups, and here we have a little chain. So here the crosshair can be quite useful. So I showed you earlier already in the video that you can just press down the shift key and then you get the square. Unfortunately, it doesn't work perfectly on while I have the Camtasia software on. But what you then can do is you can move to the next square, and by this you can actually see how the signals are connected. It's a bit fiddly, and it works a bit better when you not run Camtasia in the background, but play around with this one and see how you get on with this one. So this is one of the things I wanted to show you. The other thing is that the Ctrl Z, the zooming button, works as well. So if you press Z, then you can zoom part of a spectrum in. If you move your mouse pointer towards the top or the bottom to the spectra and use the mouse wheel, then you can increase the signals independently, so you can move them up and down. So these are additional tricks that might be useful.